Alright, so we're solving the problem to calculate the per capita rate of increase for this population. We need to show births, deaths, and per capita births, which is births out of the total number of individuals. So that's little b. And then we have per capita death, which is deaths out of the total, which is little m. And then we're going to the per capita rate of increase, so R, which is B minus M. Okay, and so after that, we're going to figure out what the population size will be in 3 years. So let's first work up births and deaths. We know that we have 221 initial plants. Okay, so that's our total. We have the number of new seeds as 63, so that'll be our births. And we have the number of plants that died as 2. So the per capita would be the 63 out of the 221. And the deaths per capita would be the 2 out of the 221. So if we do the math for that, 63 divided by 281, that's 0.29 if we round. And 2 out of 221 is 0.009. So to get births minus deaths, it's 0.29 minus 0.009, which would give us 0.276. Then we're going to do the growth rate. And so let's do that. So we know it's a logistic equation because K has been given to us, the carrying capacity. And so we're going to use the logistic growth equation. So dn over dt is equal to r times n times 1 minus n over k. Alright, so I'm going to set up my table to show all of my calculations. I'm going to start with my first population, my second generation, and then my third generation. And I'm starting with n at time t, so I've got 221. And I'm going to figure this out by first doing n divided by k, and then I'll take the 1 minus n over k, then my r times n, and then finally, all together for dn dt, rn times 1 minus n over k. Alright, so we're starting with 221, and at time 221 divided by k is 250. And then that is equal to 0.84. Then 1 minus n over k is equal to 0.116. R times n is from above, so that's 276 times by n, and here that's 221. So we put everything together, and that's equal to 7.076. So that's equal to 61.